what the bathtub was. You didn't get to choose your bathtub. You were in the bathtub, period. And if you lost your job, you went back into the bathtub. Now imagine a world where you can actually choose your bathtub. Yeah, welcome to the last lecture of labor markets with search frictions. I'm going to try to summarize what we did last time, and I'm going to give you sort of a tour d'horizon of the field without getting into any great detail. So partially this is because we insisted on doing the Pissarides model at the beginning of the class, the beginning of the course, and that took 2 to 3 sessions, and that sort of ate into the rest of the. But I think it's good because the Pissarides model was not familiar to many of you, and it's kind of a, it's a good starting point for the Mortensen-Pissarides setup, and there's just a lot of material. But I want to give you the impression that there's a lot of other interesting stuff that you can work on if you're interested. So last time we looked at the job search model and its implications for wage posting and the wage distribution. And after I look at that one more time, I'm going to take you through a bunch of interesting topics. You can modify what we did last week and the week before to have heterogeneous workers and heterogeneous firms. Remember, the magic of Burdett-Mortensen is to generate a wage distribution without any assumptions about workers being different. And that's why I keep stressing that. I mean, the frictions are enough to generate an equilibrium in which there are different workers working for different wages, and it's an equilibrium, right? So that's really quite an achievement. It's kind of a solution to the diamond paradox. But given that, you can say, okay, maybe workers really aren't identical. Maybe there are super important differences. They might have different attitudes towards work. They might have different labor supply behavior in the sense of effort. They might also have different productivity. And those things will easily result in equilibrium wage distributions. I'll mention that. I'm going to spend a fair amount of time talking about competitive search, which is like closing the circle, going back to the Pissarides model and understanding what that implies for the conditions in a local labor market. Okay, so this is a kind of a new area. In the past 20 years has been very interesting and has several key results that are worth mentioning. And to my regret, I was not able to talk about the Jovanovic model, which Thomas, when he took the course, was able to deal with, or to see. It's an extremely interesting model, and it applies some interesting tools. If you're interested, take a look at it on your own, or you can come by an office hours and we can talk about it. I will mention these other things en passant to finish up the course. Okay, so last time we looked at the implications of Burdett-Mortensen sort of taking the reverse position of asking where these wage offers come from, and if they come from in a regularized way from the observed wage distribution, you can actually have a nice theory of wages that's a sustainable distribution that doesn't change over time. It's actually, as long as the model itself doesn't change in terms of its parameters, the distribution is a stationary object. Okay, and again, we talked about wage posting. This is kind of what I think is a very important area in labor economics nowadays. If you want to do research in this area, a lot of people are now thinking about taking the notion seriously that firms actually do set wages. We've tried to ignore this since Marshall. Firms pay their marginal product. That's an assumption, but if there's any friction in the world, this won't necessarily be exactly the outcome we observe. And basically the idea is simply, if you were in a perfectly competitive world, if I lowered my wage just a little bit that I'm paying the worker as myself being the employer, that would drive the worker away. The elasticity of labor supply to me should be infinite. That's the neoclassical assumption that we teach in undergraduate labor courses or undergraduate courses in general. And the notion that may not be the case opens up this whole box of interesting outcomes. Okay, so that's why wage posting is an important idea, and Burdett and Mortensen kind of implemented it. Even though firms are competitive in their wage posting behavior, they kind of give a result that implies distribution of surplus, and we'll see later on that this is a very robust implication. So the notion, and you could also imagine a world where the workers post the wages. You basically, like you're a movie star, you basically are able to post your wage. That's less frequently the case. We don't observe that as much as we do the other way around. But one could actually write down a theory where workers actually post wages. But if you give the market power to the workers, you end up having this amazing potential for explaining stuff we observe in the world, like this equilibrium wage distribution that is very stable. Even if you control for characteristics, if you take all workers who have gotten done an apprenticeship in machine tool, in machine tools and are incredibly, well measured in terms of their capabilities, they earn different wages. And the question is, it depends on the firm, does it depend on the worker, does it depend on profits? And in the very simplest case, we can actually get a distribution even if these workers fundamentally are the same. But of course, we think they're not in reality. So I wanted to mention something before we move on, which is that the Burnett-Mortensen model actually has implications for the effect of a minimum wage. And in this model, the bottom of the wage distribution is determined by the worker's outside option, which is basically the unemployment income or benefit. Remember, that's how we derive this distribution, by pinning down the one sort of boundary condition of this function, and then we're able to solve for the entire distribution. And we pinned it by saying, okay, the arrival rate of job offers on the job and in unemployment is the same, and therefore W reservation wage, or WR, is equal to D, and therefore that's the lower bound of the support of this distribution. Well, if you think about it hard, what does that imply for a minimum wage? What would a minimum wage do in that model? Okay, suppose the government comes and says the minimum wage is higher than B. And just kind of think about, I'm not even going to derive it, just think about what it would imply. Well, no worker would accept a wage less than the minimum wage, right? Because if it's legally binding, there's no way to get around it. So that would be the new base of this distribution. So it's basically pushing the distribution up without changing productivity. So what does that imply? That implies that a minimum wage in this model is just a redistributive tool. It gives more surplus to the workers. It has no efficiency effects because the underlying frictions are the inefficiency, and they're not affected. Okay, so this is a remarkable implication of this model, which hasn't been picked on very much, but it explains a lot to me. It explains why in some cases in the United States, increases in the minimum wage have had no effect on employment. And if you look at Germany, since the implementation of the minimum wage in certain branches in East Germany in the roofing industry, or the minimum wage in 2015, we haven't seen anything yet. Okay, maybe you talk to people who are like diehard neoclassical economists, and they say, well, we haven't had a recession yet. But still, if firms are paying marginal product, that shouldn't matter. There should be some jobs that get destroyed by raising the minimum wage. And we haven't seen that yet, so perhaps we need to rethink our logic about the effects of minimum wages. In any case, it's an implication of this very interesting model, so you should keep that in mind. Okay, so we can start extending this, allowing workers and firms to be different. In fact, they are different, and some of this difference, these differences are observable. So if you're good at what you do and you show up at the job, immediately the boss recognizes that you will probably get you'll be drawing offer from a different wage distribution than the guy next to you who isn't so productive. Okay, and that's a kind of a neoclassical hope. Everyone thinks that productivity and wage should be correlated, and that would bear through in this, would be born through in this particular setup. And I'm not going to go through all the literature, but there are several papers that have shown this in the wake of Burnett and Mortensen. Okay, and you can also think about workers having different levels of effort, because workers are different. So, and workers, manager, an employer may be able to recognize it immediately. You might just have it on your forehead. I'm a lazy guy. I'm a really hardworking person. And maybe you have a signal. I went to a good university. I went to Humboldt, and you can show that, and that's a certainty. Guy works really hard. Okay, and that's the case. Then those people are going to get a better wage and a different distribution than people from less people not having this type of perfectly observable signal. I'll come back to that idea in a second. Okay, and this is one way to get around the problem that you saw with Thomas and with me actually, is that the distribution of wages in the simple stripped-down Burdett-Mortensen model is unrealistic. It's a strange-looking distribution. Even though it is a distribution, it kind of solves the diamond paradox. It gives you this extra degree of freedom if you assume that distribution of skills and effort among workers is looks like this, then the wage distribution will probably look like that as well. I mean, it'll be a sort of a compressed version of that. So go back and think about the G versus F, okay? And remember, we can only observe G in the data. F is just something that happens behind our back, or in the closed room of an interview context when the offer is made. Okay, so any questions about that? That's just a really important area of labor economics. And now I'd like to kind of go way back. I'd like to turn back the clock to the first lectures of the course, the wage outcome of the Pissarides model. So remember, Pissarides was a bathtub. Workers were the same, firms were the same. They encounter, there's Nash bargaining, and there's a wage that comes out, and the wage is the shared surplus between the productivity of the match and the fallback option income in unemployment of the unemployed worker. Remember, that's very simple. That's kind of like your benchmark. So we can actually go back to that and make use of that result by thinking about what the bathtub was. You didn't get to choose your bathtub. You were in the bathtub, period. And if you lost your job, you went back into the bathtub. Now imagine a world where you can actually choose your bathtub. So you have the luxury model here, and you have the tin basin there, and maybe you can go in the lake. All these different options for taking a bath. And in some sense, you're free as a worker and as a firm to choose where you want to do your searching. So that's called competitive, or it's actually called directed search. And the outcome of that is the model that I'm going to try to describe, which is the model of competitive search. So remember, the bathtub, strictly speaking, single bathtub, Pissarides, was a random search model. So that's something that's a word that you should understand. Random search means you wander through the street, you bump into people who might hire you and not. That's kind of one simple way of understanding everything that goes on in labor markets with search frictions. But actually, people are not so stupid. They actually they take decisions that rule out stupid bathtubs. So why should I look for a job in the market for medical practitioners or doctors, nurse practitioners, or even chemical engineers? I mean, I could try, but it's probably not gonna lead to an offer. So I would just shut that down. I would save my money, my effort, my anxiousness, and just do other stuff. Go elsewhere. And this notion is called directed search. So you choose where you look. Okay, so that's a fairly reasonable idea. And the notion would be that firms can also do that. Why would a firm, looking for people to work in a restaurant, post vacancies in a hospital to try to? It's just not likely. You could imagine certain conditions where you might be able to find. You might find taxi drivers who have engineering degrees, but it's generally not the case, and it may involve other problems. There might be some losses involved, but it's something that people have also thought about. All right, so the idea is really simple, but it involves the wage posting idea. Now, who wants to remind me how was the wage determined in the Pissarides model? The very first model we encountered. It was Nash bargaining, right? So it's a very simple but extremely powerful assumption. Nash bargaining. So you and I actually get to haggle, and the Nash solution is we take some combination, some linear combination of our fallback positions, and that's supposed to stand for maybe a complicated war of attrition or waiting game or something like that. We don't even get into that, but that's the Nash. The Nash is a shortcut And the original Nash paper was split the difference, right? You just take a simple average. And then the so-called modified Nash solution kind of gives one side or the other a bit more bargaining power. But that is, of course, not exactly what we observe in the data either. We tend to observe firms posting wages, and that's what this competitive search model is based on, the idea that firms actually post the wages. Okay, you still have a matching process, but you have sub-markets, and firms can choose where they want to go. They can't be in all different markets at once. They have to choose. And firms are small. They're atomistic, so they hire one person, just like in the Pizarrides approach. So you can think of different ways of thinking about that. You can think of the firms posting the wages. That's one we're going to talk about. But you can also think about a market maker, like a broker. Okay, like that's what we think brokers do. Like in Berlin, if you want to buy an apartment, it's really hard to find someone on the street who's selling an apartment. You have to. The reason why these people make so much money is they're solving a search friction. A broker, a real estate broker, and in good times makes lots of money because they put people together, right? You don't want to post an ad in the Tagesspiegel saying, I got an apartment to sell. You'd be overwhelmed by garbage, just people trying to play with you and unserious people. You want to have serious people to negotiate with. And that's one way of thinking about a market maker. That's one way we solve, and a lot of people don't like this. A lot of people don't like the idea that brokers make money on the market, but that's the way it is. And the more competition you have in the broker's market, the less the margin's going to be, and the more competitive it's going to be. And if you talk to a broker, they say, well, if you do that, you're going to ruin the market for brokers because you're going to ruin my income, but you're also going to make a lot of marginal guys come in who don't know what they're talking about. Okay, so this is, you want to have some qualified people doing this. So you can take that approach, and that's a very nice, if you're really interested, read the paper by Espen on this idea. Second idea, if you read the Rogerson Chimera Wright paper, they go into this in a little bit more detail. An alternative would be that the firms actually post wages in the market. So they go to the market and they say, okay, I'm willing to pay €5 an hour, I'm willing to pay €10 an hour, 15 euros an hour, and we'll see what happens. Okay, but now all workers are the same in this world. So it's not like Burdett Mortensen modified or the rest, and you're not going to get an equilibrium distribution. And you can also think about workers posting wages. I mentioned that already. So these are all kind of go in the same direction, and under certain conditions they give the same outcome. But we're going to focus on two. So I'm just going to sketch this model. I'm not going to ask you to regurgitate this. So just relax and think about the Pizarrides model. Think about this, and if you're interested, you can read about it. Okay, but the idea is take those ingredients from the very beginning of the course. So if you go into a certain market, sub-market, you have to deal with, you're competing with, if you're posting a vacancy, you're competing with others. If you post a wage, you're going to get a certain response from the market in terms of workers applying for your job, and you're going to get, that competition. We're going to call the length of the line, the Q. Okay, so think of labor market tightness as being an inverse measure of the length of the Q. So if V over U is high, that means that it's easy for you as a worker to get a job. 1 over theta is low, and the expected time that you'd have to, if you're just standing in line, or if you're just standing in a horizontal line and the workers just get called out randomly, the longer that line is, the less likely it is you're going to get a job. So we call that the Q. So you can think about this sort of this model is based on the notion that the higher the wage in a submarket, the more people are going to be lining up to get a job, and therefore the less likely it is that you're going to get it. Okay, so it's this trade-off. And firms have the same trade-off. The firms, if they post a vacancy in a congested market where there are lots of other firms posting, they probably won't get the worker, and it's probably because the wage is too low. So we're going to have like a trade-off between the wage in a submarket and the length of the queue. So this makes a lot of sense to me. If you think about the best paying academic jobs in the United States, they pay really well, and a lot of professors would love to have that job, but they're not going to get it. Okay? And on the other hand, if you're in a market where the wages in equilibrium is relatively low, the workers are, like in Germany right now, all the German employers are complaining about not finding workers, and wages are kind of low. We know that from all sorts of comparisons with other countries and the like. So you can think of this as a trade-off. And therefore, in a wage posting world, the firm has to take this into consideration. We're going to give the firms the power to post a wage. So it's the option number 2. The firm goes in and says, okay, €5 an hour. What happens? That's one strategy. It could pay €10 an hour. And basically, in an equilibrium, the firms are all the same, the workers are all the same. The labor market has to have the same wage combination with the length of the queue. Okay, and then the worker and the firm could go to other labor markets because they're all the same in the end. Because they're the same, it's like having different bathtubs, but qualitatively, they're all the same. All right, so, I mean, again, you can jazz the model up and make the labor markets different, but for the sake of the argument, imagine n different bathtubs, and they're identical, and firms can post a vacancy in any of these bathtubs, and workers can search in any of these bathtubs. And basically, the trade-off for the firm, when the firm chooses a strategy for the wage, is I know if I set a really high wage, I'm going to get lots of applicants, but I'm going to lose money relative to posting a low wage. It's the same trade-off we had before. Okay? And the cool thing about this model that Espen proposes is that there's a fallback level of utility. Basically, if you have n bathtubs out there, the worker and the firm have to deal with the fact that if they do a lousy policy in this bathtub, they're not going to get any contacts. So, and they have to offer a certain amount of utility, expected utility to the worker. So the combination in an equilibrium, the value of expected utility to the worker, let's call it U bar, has to be achieved by any of these labor markets. And that labor market utility is a weighted function of getting the job at wage W and not getting it at unemployment income B. And the weights are exactly the rate of success, finding the job and not finding the job. So remember, F is the finding rate. I'm using the notation from Pizarrides. And if you read the Rogerson Wright Scheimer article, they use a slightly different notation, but it's the same thing, okay? So F is the success probability from the worker's perspective. Remember, Q is the success probability from the firm's perspective, and they're related to each other using the usual identity. So, these are expected utility maximizing people. So if F is high, for a given wage, that's going to yield more utility. So maybe something else can be lower. And the idea would be that firms would never dream of posting in any labor market that gives a combination that's of utility in the two outcomes. It would be less than U bar. So U bar is given from somewhere else. It's just like it's some external level of utility. And this is like a constraint. So when you're choosing your own firm posting policy, you have to consider the star as like a budget constraint. Okay, so if I'm offering a high wage, I'm going to get lots of success, but I don't need to do that because the U bar is the alternative, right? So think of it as like a budget constraint from the firm's perspective. Again, holding B constant and thinking about this matching function, which is invariant across markets. Okay, so basically it means that there's just like in the Burdett-Mortensen model, if you post a higher wage, in that model it was different because you're in a model where there are wage offers on the job, et cetera. This is a different model. This is a model where you hook up with the worker. It's basically you've got a match. That's the idea. That's the simple version of this model. Okay, and all you have to do is add a little cost for the firm. The firm can't do this costlessly, otherwise it wouldn't be an equilibrium. So the firm has to pay K to play, and then you ask, what's the zero profit condition given optimal behavior by the firm? Okay, so the firm solves this maximization problem. Oops, sorry. Okay, so you can think of the firm as choosing the wage and the tightness subject to the constraint. And if the constraint is binding, the constraint we had before, that's the star. This is the constraint the firm faces. So for any labor market, the firm has to face this constraint, and in equilibrium, this constraint will be binding. So we'll basically impose that, and then we can substitute either W or theta out of the problem. So it's a simpler problem to solve. Okay? And in the paper, those guys are, you think of firms posting the wage, but it's equivalent to choosing the tightness. You choose one or the other. You can't choose both because U bar is given. So to make this really tractable and easy to solve quickly in 15 minutes, you can just substitute out the wage. So effectively, the firm is choosing through its wage posting policy the level of tightness that it's to expect given that wage. So again, if you come to Berlin and you post opening a branch of Amazon, you post a really high wage, you're going to get jillions of applicants. Okay, that's clear. But you're going to pay a lot more than you probably would have to achieve the fallback utility U bar. So a firm wouldn't necessarily do that. And in fact, it's kind of choosing the number of applicants it's going to have to process by its choice of wage. Okay, so in this slide, I basically substituted for you and show you that's formally the case. So it's really an unconstrained maximization problem like the last line. So effectively, the firm, implicitly in choosing its wage posting, is going to be choosing the number of applicants it gets. Okay, that's like theta. It's the inverse measure of the Q, because if firms are posting a really high wage, then they're not going to. The equilibrium number of vacancies is going to be lower relative to the unemployment in that market. Okay, so the first order condition looks like this. Again, it looks quite simple, actually, doesn't it? I mean, and again, if you know the optimal theta, which you get from this first order condition, you can plug that into the constraint and get the level of wage the firm has to pay given theta. Okay, and again, all firms are the same, so in equilibrium they're all paying the same wage in that labor market. And in fact, if all labor markets are the same, it's the same wage in all labor markets. So it's kind of a simplistic model, but it gives you a model that has wage posting behavior, and it gives you an equilibrium concept that's defensible. Okay, so that's why this model has actually been very popular. And the most important thing is this next expression. So you can look at the wage that the firm chooses optimally in an equilibrium, and you can see that it's based on the same stuff that we had in the Pissarides model, which was a model of, random search with Nash bargaining. It looks very similar. It's not the same, but look carefully at it. Okay, it's W star is an average, some sort of weighted average of the fallback position of the worker and a markup, and that markup is kind of. It's the elasticity of the matching function with respect to theta. Okay, so remember the Cobb-Douglas, that was constant. We had the Cobb-Douglas case. It's like the alpha in the Cobb-Douglas function. 1 minus alpha, constant returns to scale. So, and this is a more general result because it says, well, maybe this elasticity is not constant. It may actually depend on the level of labor tightness in the market. And all we have to do is impose that the elasticity is no greater than 1 and no less. It's not going to be less than 0. So it lies in the closed interval. Okay, so this looks a lot like what we did in the Pissarides model. Think about it. This is the wage is kind of a mixture, or it's a weighted average of the fallback of the worker and a share of the surplus of the match, which is Y minus B. Y is constant. Across firms, there's no difference in this model. There's no difference. So you're still getting this interesting sharing notion, but it's not coming from Nash bargaining anymore. It's coming from this posting behavior. Okay, so this is why this paper is so important if you're interested in doing this for a living. And you can, this is taking it to I'm just writing it out, the solution. So that's the solution. Now, this result says that we have a sharing result, And if you remember the Cobb-Douglas case, this epsilon, this elasticity of the matching function with respect to vacancies, or the vacancy unemployment ratio, is constant, okay? And it doesn't depend on theta, and it's taken by the market participants as given. And you can see that in that result, the higher epsilon, the higher the wage, right? So, and what is it? Epsilon is kind of like the sensitivity of the matching probability for the firm if there's a small change in this labor tightness or the length of the queue. And you can, if you think real hard about it, this is a little bit like the elasticity of labor supply, because it means basically the firms, if they change conditions in that labor market, it's not going to change their power to post a wage or not. In fact, it's going to nail it. So think of it as like almost identical to the elasticity of labor supply in a model of monopsony, where the firm has local labor market power and is able to set the wage above or below the workers' marginal rate of substitution of labor for consumption goods. Okay, so this is a really interesting, I find this a really interesting result. And just to summarize, what do we need to get this model, which I'm just sketching for you. We're not going to go through this, I think you should understand the idea, and not, if you're interested, you can read in the paper. Free entry across many labor markets, wage posting behavior, constant returns and matching, and of course a notion of arbitrage. So firms can basically look at these two bathtubs and decide, I'm going to go here, I'm going to go here. In equilibrium, since everyone's the same, the conditions have to be the same in all these different local labor markets where you have directed search. Okay, and the interesting result is that this outcome that we just had with the elasticity, okay, that outcome with epsilon is not the same thing as we had in the Pissarides model. In the Pissarides model, we had the Nash bargaining parameter instead of epsilon. Okay, now I'm assuming you're all boning up for the exam. So you remember the Pissarides model. We had the same kind of wage equation, but we had this Nash bargaining parameter. So you're saying, wow, that's interesting. Could it be the case that those two are equal, right? And this is what Hosios' famous paper basically showed, that a central planner trying to maximize welfare in a labor market would actually choose the sharing parameter to be the elasticity of the matching function. Okay, so that tells you one thing: the Nash bargain outcome may not be optimal. The workers may have too much power, or they may have too little power. And if you nail it, then you've reached the best of all possible worlds. So if the Nash bargaining parameter just happens to be the elasticity of the matching function, then we're in heaven. We've reached nirvana. Okay? Otherwise, we might want to think about trying to affect the bargaining power of workers and firms. Okay, so that's a really important result. It's called the Hosios condition. And in a better course, if my course were better structured, I would have put this out at the very beginning, and I just kind of neglected that. But Pissarides talks about it in his textbook, because you can take the Pissarides model and try to optimize that thing and say, okay, well, is that the best result? And the answer is no. Okay, and Hosios gets the credit for that condition. Okay, so even if this is a model that doesn't have any Nash bargaining at all, and you can see that competitive search could lead to the optimal outcome, and that's why Espen Mohn's paper is so important, because he actually shows in a competitive search outcome under certain conditions, which I've already talked about, we can actually reach the Hosios condition even though we don't have a central planner. Okay, so for a lot of free market guys, this is like a great result. It's an interesting result no matter what you think. Okay, and it shows maybe what we need to look towards, because you can imagine worlds where you have too much worker power, too little worker power, and indeed from a social planning perspective, a social optimum perspective, there is a correct value of that sharing parameter, and it may not be the right one if you let people just bargain. Okay, so any questions about that? That's a really interesting area of research. People are still working on it. You should remember the Hosios condition is kind of important in general. All right, so now I'm going to talk a little bit verbally about this paper, which I really like. I still like it. It's a perennial favorite. This is another extremely productive economist at New York University who's just been, he's amazing. He's like probably, I don't know, now he must be well into his 70s, and he's still producing interesting papers. So now this is a verbal summary. So believe me, this would require at least a lecture to deal with. So I'm not going to ask it, in an exam context, but you should probably understand the principle, because there are some interesting facts in the data that have multiple candidate models to explain them. And one is that wages rise with job tenure. The longer you work at a job, statistically, the higher you're going to the higher the wages you're going to earn over time. And actually, if you're interested, you can actually estimate this thing using different types of econometric procedures. You can use a parameterized functional dependence on tenure. You can look at non-parametric, and you get something that looks like a concave function. So the first, say, 10 or 15 years of your job, your wages tend to rise, and then statistically, after maybe you're 50 or 55, they start to peter off, sort of fall. And there are lots of econometric issues why that might be the case. It might be selectivity. People may just retire, and the people who retire are the ones that don't earn as much, so you end up observing the wrong, a biased sample. But forget all that. Just suppose that this is a fact. It's a fact that wages rise with tenure. The stuff at the end of tenure of your working life might be a bit subject to discussion. So there are three candidates. We already talked about these many times. And if you take my labor course next semester, we talk about it in detail. So the classic explanation is that, when I work for you, I'm learning all these things, and some of these things can be used in other firms, okay? That's gonna make me more valuable. So I could always threaten to leave, and you have to pay me my productivity. So that's probably the less obvious version of human capital. A more refined version is that I learn stuff that is only useful with this firm. Okay, and if I leave and go somewhere else, my wages go down. So the question is how is this compensated? And depending on the specificity of human capital, it may or may not be compensated as much as general capital. Okay, so that's just one notion. Experience gives you productivity, and the firm pays you for it for whatever reasons. Maybe it's because you've contracted it, or maybe it's because you threaten to quit. We learned in this course that a second reason wages rise with tenure is just because you're lucky. You survived, and you survived with the firm and got better offers. The older you are in the Burdett-Mortensen model, the more likely you are to have gotten good offers that increase your pay as you reach the top of the distribution. Remember how that works? So that's kind of I like that explanation as well, because it predicts that identical workers may actually earn different wages. And the last one is about information, incomplete information. So, not surprisingly, there's construction, but don't worry about it, it doesn't matter. Wow, that stops the course. Okay. Yeah, and the third alternative I'd just like to talk about briefly. Again, deriving it would require a bit more. It's just, we've had so many models in this course, it's kind of, at some point you have to stop, right? But I think it's worth mentioning. And the idea is simply firms and workers don't have complete information. So you meet a worker and your employer, and you just don't know if this is going to work out or not. So there's some match specificity, and it's not completely observable at the very beginning. So it's different from, say, the model with search that we had before, where the wage of the productivity of the worker is changing over time randomly, and you can, the worker gets his productivity or her productivity. We're going to talk about a situation where now we don't know if the information we have right now is a good indicator of what the future is going to hold. Okay, so this is a verbal description of a very reasonable alternative. And the notion that Jovanovic pushes is that over time you do learn, you do understand. If after a trial period, you get to know the worker as an employer, or the worker gets to know the firm as an employee and says, this is not for me, this is not going to work out, so we separate. Okay, so this is a third way of explaining why wages rise, because it's a selectivity problem. So we observe the right matches, the productive ones, and the ones that were lousy, the duds, are just not in the data. Okay, so it's a selectivity argument. It's a really clever, and the version that I teach usually is quite simple. It's not a complete general equilibrium, which is a bit harder, but I can probably give you enough insight. There are a couple of very important tools that Jovanovic uses in this model that are useful for you if you do other research or do work in this area. So we need incomplete information. We need to have a situation where the first encounter in this bathtub of undirected search, that's the context, would be that you don't know exactly the productivity in the long run, okay? So think about hiring an assistant professor, maybe may have had a couple of great papers and makes a great impression, but maybe the person's a lousy teacher. And the university says, well, we're not gonna keep you. That's kind of one way of understanding a fixed-term contract or an apprenticeship. All these different things are ways of, and we've already explained apprenticeships in different contexts, but this is one way of thinking about the problem. And again, you have search frictions, so it's not going to be very rational for you to just reject anything that comes up to you because you think it's got to be perfect, because maybe there's a trade-off. If you may not meet somebody for a while, so a bird in the hand is worth more than two in the bush. That's a classic sort of English expression which applies in this case. Firms and workers are not risk averse, so we're going to eliminate that as a possible reason, although it could easily be put in, and you can jazz up the results commensurately. The idea is simply, what are the incentives that are facing workers and firms given this informational imperfection? Okay, so I'm going to talk about 3 periods. Again, this is all verbal. I just want you to sort of imagine what would happen if you had a model in which there was a meeting period, or there's a juncture where the firm and the worker come together in the search, in this random search mode, and they draw a productivity signal, okay, or we're going to call it an observation, okay, and it's basically, it's a noisy signal, so it's going to have the truth and it's going to have some noise, and the noise is random, and the signal will also be random, so the productivity of the worker could also be distributed arbitrarily. And because it's a partial equilibrium approach, we're not going to go into detail on where that comes from. Okay, so we just have these 2 exogenous components. And the second part of the model is that workers and firms decide jointly whether to try. So it's like first date, and then if it works out, you can get married. It's that kind of thing. So the first date is this agreement to form a match, and there may be a negative decision. Firms can and workers jointly decide not to have a match. So there's no disagreement in this model. Firms and the workers have the same information set. Okay, remember we talked about, again, I make recourse to our knowledge from the Mortensen-Pissarides model, where you actually had a similar situation. Workers and firms observed this idiosyncratic shock, and then they were deciding whether to keep on going or not based on a sort of a threshold measure of acceptable productivity. Well, this is similar, except in this first period, in this first encounter, this signal is, it's not the truth, it's a signal of the truth, and it's going to have a noisy component that the workers and the firms have to jointly filter out, because they have to make it, if they just If it's a lousy signal and they say, well, we're not going to do this, that might not be quite rational because maybe the noise just happened to be very bad in that. Like you have a first date sometimes doesn't work out, right? You might, if you're clever, you think hard about this, really hard about this, given all the frictions and everything, and you might find some encounters to be more acceptable than they would if you were just a radically applying the knife at a much more stringent level. Okay, and then the third part of the model is actually the truth comes out. So after we've encountered and we've worked together, we basically decide this is really going to work out or this is not going to work out. So in this extreme version of the model, we actually observe the truth. The noise goes away, and and if you're interested, it's in the Sargent textbook or the Lundqvist Sargent textbook for macro. So this is the end of the line. Basically, either we stay together forever and think about the first models of search that we had, or we separate. Okay, so again, a really difficult version of this model would have future separations and then future encounters, and you have a lot of information to carry around as state variables through the model. It's very hard to do that. So this is a very simple way of getting an idea across, a partial equilibrium idea across efficiently. Okay. Any questions about that so far? That's pretty straightforward. So we could have done this in detail, but I'm just going to give you what I think are the very important ideas behind this model. So the idea is you have a signal and you have a noise, and workers are observing and firms are observing a sum of these two. So they can only observe the sum, and they have to take a decision based on this information. And this is a general class of problems called signal noise problems, and everybody probably has seen them in some respect. Lucas made this very popular in the 1970s when thinking about inflation. How do workers forecast the rate of inflation? How do firms forecast inflation? Well, they observe some information and try to make inference on the true policy intentions of the central bank by looking at the inflation rate. Okay, and here we have an observation of, we call it Y. So that's our productivity in this first trial period. And it's going to consist of the truth X plus this noise epsilon, and both are normally distributed covariates, and the distribution is time invariant, so over time these things don't change. Again, that's just for simplicity. So it's all about learning the truth given this noisy observation Y. Okay, so we're going to meet. We're going to decide whether to give it a shot based on Y, but actually it's based on the expectation of X given Y. That's the true thing we're worried about. Okay, so it's a basic result from statistics that if both of these are normal, then the usefulness of the signal is going to depend on the correlation of, well, it's going to depend on the expected value of X, which we have in the back of our heads already, and then we have this correlation of Y with the truth, and that sort of gain or adjustment to the mean, given this information Y, is going to be based on the correlation of the two. And the correlation of the two is based on the noise relative to the signal. So if you have a really noisy signal, if U has a very high variance relative to the variance of X, then you're probably just not going to pay attention to Y at all. But if U has a very small variance, then X is a very good indicator. Y is a very good indicator of X, and therefore we're going to put a lot of weight on that observation. Okay, so that basically will determine where I draw the line in accepting matches or not. And when I say I mean I worker or I firm, because we have the same information. There's complete agreement. Now, sometimes you apply for a job and the guy doesn't want to hire you, or the firm doesn't want to hire you because, and you just don't understand why. Well, this is not the case in this model. Everybody understands. It's just clear after one go. We have this observation why, and we're going to make a decision based on that. Okay, so that's and then so you're going to basically have false positives and false negatives in this model. You're going to have some matches that are accepted, which if you had known X from the start, you would have said that's a bad idea. And then you might have some matches that were rejected, but could also have worked out had I known the truth. Because remember, U and X are random variables, so you might have a really high X, but you had just a really bad day, or maybe your first date was terrible, just polluted the noise polluted the value of Y, and so you're going to have some of this in this model. You're going to have some bad decisions, but you're doing the best you can. Given the information set, the information structure, you're going to be doing the best you can. And then in the final period, we have the classic match search problem, or, sort of the classic problem. You actually observe Y, and you have a fallback position, and the firm knows that fallback position, knows knows what the frictions are, your probability of finding another offer if there's a rejection, etc. So that's gonna be just the classic problem. And the problem is when you do this, you have to really think forward. You have to look to the end to the last stage and say, okay, what is my behavior going to be? What is my reservation productivity level going to be given I know the truth? Remember, X is also a random variable, just like in other models we've dealt with, like in the Mortensen-Pissarides model. So think of the last period, the third period, as being the one where we have to decide on a reservation level of productivity given that truth, be it good or bad. So when we learn the truth, we might actually split up because we know maybe we had a good first date, but it's not going to work out. Okay, that would be the case of dissolving the match in the last period. There's one American in this class. You know what a dud is, right? So it's a bad one. Okay, and in the model, you actually go to the last period and you solve backwards, because when you find the reservation level of productivity in the final period, you need to know that to find out what the value of accepting or rejecting a noisy signal in the second period is. Okay, so you can only start in the back and then work forward, and that's why this is called backward recursion in this very simple model. I'm not going to write that out, but it's very interesting because you basically have a value function based on the final complete information set, and then you have a decision based on the value going forward that you would have when uncertainty is resolved, plus the fact that you have this noise going on right now, and you have to deal with that. Okay, so this is kind of I just want to inspire you a little bit because it is a very interesting way of thinking about things. It's a classic way of looking at decision problems under uncertainty when your information set gets resolved. And you can think of models, versions of this model where uncertainty never gets resolved. You only get a little bit better over time. So every period you get another observation of your productivity, which is still noisy, but you're learning over time, like Bayesian learning. Every period you would update your expected value of the productivity, of true productivity, and they have this type of twist of the model would have a very similar type of prediction. So this model can actually predict a lot of very interesting things. Okay, so first it does predict that wages rise with tenure. Okay, because the people you observe in the third period, and the people that continue are going to generally have higher wages than those in the second period. The wage is simply your productivity. So productivity and wages rise together with tenure. If you think about the dissolution of a match as being like a quit, then the higher the wage paid at the beginning, the less likely it is that the match is bad and will be dissolved in the future. So you end up having this negative correlation that we observed in the data. Okay, and again, you can think about this in terms of apprenticeships and the like. Those who survive the apprenticeship and get a raise are the ones that didn't leave in the end. Okay, and also the high wages today are correlated with lower quits in the future. Okay, so again, you can interpret that as we've already interpreted that differently as behavior of employers trying to reduce turnover, but it could also just be the fact that a good signal today, signal plus noise, would lead to a high wage today, and the worker accepts it, and indeed that's going to be correlated with lower quits in the future because it's likely that signal is reflecting the truth. Okay, so it's an alternative. Any questions? I think I'm killing this. I think we're gonna finish. I probably should have done Jovanovic. I just didn't want to do it. But Thomas is happy. All right, so let's look at some other models. I'm going to just give you a last few set of interesting models that turn me on. I like this. So there's a whole set of models of discrimination that you can look at that use the search principle or search and matching approach. And the way you can think about this is the reservation wage that determines your threshold for accepting a job or not depends on the future. Okay, so suppose you're in a world where there are certain employers that are fair and don't discriminate. And when I say discriminate, I mean they just turn you down. So you have an encounter. Think of the alpha from alpha 0 from our search model. Basically, there's an extra probability that conditional on meeting someone, this person is just going to discriminate against you for whatever reason. Okay, so we won't talk about just you're a B person and B persons get discriminated against relative to A people. Okay, so suppose we're in a world where you have A people don't discriminate, and B people do discriminate. Okay, and you're a person who could be discriminated against, and you're trying to solve this search problem. You're solving for your reservation wage in that type of environment. You don't know ex ante who you're going to meet. So what do you think is going to happen in a model like that? Maybe just ask you. What is your intuition? If you have a probability of, your alpha is now conditioned on basically meeting a proper employer, a non-discriminating employer, and a discriminating employer. How do you think that would affect your decision? Remember, if you meet a discriminating employer, you don't get anything. So you had your alpha chance, and you get nothing. You just get 0. So how would that affect your behavior? Just intuitively, think about the search model. And think about it as opposed to someone who is not the object of discrimination. It goes down. That's right. It affects it because, in a sense, it's not. I mean, you call it a fear, call it whatever. It's a rational response to having a large string of possible events that lead to no offer. Your reservation wage will be lower than that of a person who doesn't have this problem. And therefore, you're going to have, in this model, you'll have a situation where even if you meet a non-discriminating firm, they're going to pay less, right? I mean, they're going to end up getting workers for a bargain, even if they're not discriminating officially. Okay, so think about it. The implications for those good guys, those firms that don't discriminate, they're going to say, well, the guy was willing to work for me at this low wage, right? But it's actually because the fear of spending a lot of search effort and time encountering discrimination leads to sort of a more modest expectation for those workers who have the attribute that's being discriminated against. So this is a set of models that Dan Black elaborated. The 1995 paper in the Journal of Labor Economics is the one to look at. And that can be, that raises a bunch of interesting policy questions, like how should you deal with this? Right? That's because it's very difficult to prove that a person is discriminating if they don't really do it explicitly. It's hard. Okay, so this is given a lot of people, you know, for example, you can think of women versus men in the labor market. It's a great example. A lot of women know that there are men out there that are employers that may discriminate against them. Okay, so that's going to condition their behavior. There may be other things. There might be expectation of fertility in the future that may also affect they might expect an employer to behave badly or not so badly, and that would also reduce their reservation wage. So this is an extremely interesting area, and the policy implications are not exactly clear, but they may, under certain conditions, argue for interventions that a lot of people have been advocating, like sort of a mandatory equality. On the other hand, you might say, well, who cares? You know, that's their problem. So this is a huge debate. I would not take that position, but it's worth thinking about in your free time. Yeah, okay, so that's the first class of models I think are interesting. And again, there's a lot of other stuff. Here's another more complicated set of models which involve, maybe I should actually separate these as being two separate, but they're both kind of interesting. So think about the possibility of actually posting not just a wage, but a wage plus a promise to increase wages over time at a certain rate. So think of that as like a contract. So like if you're a soccer player, you get a certain base salary, and then she gets a raise of so and so much every year, maybe even conditional on performance. Because that's a different type of posting. That's a contract. So you can imagine a much more complicated world where firms post not just an initial wage, but also a trajectory. Now, why would they want to do that? Why would they want to do that? Right. And in what sense, keep the workers? I mean,
to reduce turnovers.
Okay, so to keep workers from leaving too early. And you know, of course, you can make it conditional on performance or not. This is a way of reducing turnover costs in general. So you bind somebody, and again, the worker has to give something. The worker trades freedom for that. So there might be some, again, the search model tells us that these things are costly. We know that search is costly. If you don't have a worker, you're dealing with a no production situation. So this is a kind of but it's not free. And of course, the legal enforcement. Think about non-compete agreements, right? This is a big discussion in the United States going on about firms offering workers contracts, but making them sign that they're not allowed to work for another company for the next 3 years. Now, why would you want to do that? This is a kind of an insidious. I mean, it's a bit dubious as a practice from if you're just taking if you want to take the worker's perspective. So why would you want to do that if you're a firm? And let your mind wander. Why would you do that? Non-compete agreements. So it really is kind of restricting your freedom. So it means that after you've been in the search model for you look for a job and you separate, you have to stay away from all other firms in this sector for 3 years, sometimes it's 1 year. So are there good reasons, bad reasons? What do you think?
As a worker, I would do it only if it really pays me hard.
Okay. But if you're a firm, why would you demand this from a...
If I'm a firm, of course, to keep the information like a secret within the firm.
Perfect, right. So we observe this, and my colleagues will tell you that this is fine, this is free markets. If you're working for Microsoft and you're doing serious coding for those guys, should you be allowed to go to Facebook and tell them everything you've been working on? Okay, that's kind of legitimate. It's one of the problems with information, I don't know, do you have any good solutions for that? I mean, you can try to patent things and make it impossible for firms to copy, but that's not usually so easy. It takes a long time to patent this stuff. Okay, so why don't we just have a show of hands? Who thinks that's a good idea? There's no right or wrong answer. I mean, do you think it's a good idea for the tech firm to impose a non-compete? Thomas, what do you think? Sure. Okay. You guys, you okay with that?
From the firm perspective or general?
Well, first from just your personal perspective. Well, in a sense, it is kind of giving the firm all the rents of your joint effort, okay? So you may think that's unfair, but maybe the firm has huge bargaining power, like they do in Silicon Valley. They just sort of squish you, right? Okay, so that's, remember, there's economics, positive economics, just to assess the situation, and there's normative economics, try to understand, try to make a judgment. I think that's terrible. But understanding it, it's pretty easy to see what's going on, right? And of course, if you've contributed to the programming, it's not clear why the firm gets all the rents. So I'm not so sure I know what the right answer is, but I know that there's a lot of surplus there that could also go to the worker. So the worker could take it with him, right? So maybe that's why they can't make it more than 5 or 6 years. I mean, that's a long time in the life of a programmer, not to be able to work for anybody else. It's really hard, okay? So I'm going to tell you something else, which may surprise you, is that in American fast food industry, if you're a manager for several important companies, I'm not going to mention them, they make you sign these NC agreements, non-compete clauses. So, what could be such a trade secret at McDonald's that you couldn't take to Kentucky Fried Chicken? Okay, so think about it. Okay, so now if you talk to those guys, they may say, well, we have a secret frying fat that we use to make the chicken, and we give it to the competition. This is a trade secret, right? They should have a patent on that, but they may not. Okay, but what else could they be doing? What else could they be doing at the same time? I mean, you said it yourself. Non-compete clauses have several effects. One is keeping you from going to the competition. So it's like reducing the elasticity of your labor supply to this firm. In fact, it's setting it equal to 0. It's making it really hard. If you can't work, you want to work for a living, and the firm says you cannot work for anybody, and suppose you're, I mean, it's not going to be 0, but it's going to make it pretty low, because you're not going to quit to work in some other industry, especially if you're maybe a manager of one of these restaurants. So this is a case of creating monopsony power through a contract, non-compete agreements. So this is hugely controversial in the States. When Obama was president, there was much more interest in researching this, and surprise, surprise, in the new administration, there isn't much interest. Okay, there's actually I think the Secretary of Labor was also involved in the industry. So it's really interesting to think about. It's related to this contract posting business because that's how firms compete. Okay, so before you sign on the bottom line, you're free to choose. You can go to different companies. But if they're all doing the same thing and they're offering the non-compete clause, then things don't look so good. Okay, so this is an extremely interesting area for research. And there's also a fringe area where they actually look at people's behavior after you sign the dotted line. So in America, a lot of times you sign the contract, and then the firm comes to you afterwards and says, oh, by the way, you have to sign this. And you've already signed, you've maybe even gotten your first paycheck, and they ask you to sign the non-compete agreement. So what do you think about that? I mean, you've got to, I mean, it highlights what search and matching frictions is all about. If you've gone through the hard work and you've found the firm, you've searched for months and you've got the great company, the great match, and you're there. And then the company comes and says, okay, now we're going to renegotiate. I'm going to impose this on you. So, is that right or wrong? See, and then you get into this, it's kind of almost like a hold-up situation you've encountered in microeconomics. Okay, so this is incredibly interesting, and again, I think there was a time when this was completely illegal, and now, So when you sign your contracts, when you start working for somebody, make sure you read the contract. And of course, it's probably going to be 50 pages, but it's probably worth your evening to look very carefully at the details. Okay? So the last topic is wage bargaining. So we're going to think about, just check this clock is wrong. Time has stood still on that clock. So this model is about different and more complicated forms of wage bargaining. So this is really kind of fancy stuff. So imagine you're in a world where you've got a wage posting model. The firm has you in hand. You're working for them, and then suddenly you get an offer from another firm. Remember the Burdett Mortensen model? It's so simple, very clever idea. And now we're going to give the worker a chance to fight to cash in on this offer. So this is what happens at universities sometimes. If you're a really famous professor, you get an offer from another university, and you go to the university president and you say, hey, what are you going to do about this? Now, why would you do that? Because we have a labor market with search and matching frictions, and it's painful for the professor to leave. And again, I keep using professors because it's kind of it's an example that I know well. But if you're a baseball player, soccer player, if you're a top lawyer or you're a CEO, you get these offers, and to leave your present position is painful. So one natural option is for you to turn around, go to your boss and say, look, I got this offer, can you do something for me? So that is a Nash situation suddenly. Then you have, we hadn't had Nash in the Burdett Mortensen, but you can actually introduce it ex post when you have this offer. You can actually turn that into a situation where you may not leave, because the assumption was in the Burdett Mortensen is if you get any offer that's better than what you have, you're going to leave, right? It transforms the offer distribution into a different wage distribution that we observe. And here we have a situation where you may actually have a cost-saving measure by the firm to say, look, we really worked hard to get you, and maybe we'll split the difference. Okay, and that's kind of what we observe often, not always. And in industries where there are lots of unions, this is usually not allowed. Okay, so there might be work rules, labor market institutions to prevent this type of competition, but it's very, very interesting. We do observe it increasingly in the service sector, where workers are less likely to be unionized and less likely to have work rules. Okay, so again, you can see why I get really passionate about this course, because there's just so much interesting stuff in there. So you should really take a look at the parts of the survey article that I keep mentioning by Rogerson, Scheimer, and Wright, because it's kind of points, even though it's 10 years old, it's still 14 years old. It's still a very interesting article for new and future directions. Okay, so I'm basically done. That's it. So, are there any questions? Any questions about the final? Okay. Yeah, then have a great summer too. If I don't see you.